Hi, I'm Arnie Gundersen from Fairewinds, and today we have a very special guest, Mycle Schneider from Paris, France. Mycle was honored with the Right Livelihood Award, which is also called the Alternative Nobel Prize, for his work on plutonium. In addition, he's been an independent consultant on energy matters around the world for decades. So I'd like to thank you, Mycle, for joining us.
Well, thanks very much for having me.
You know, Mycle, when I am out on the stump speaking to people, the impression here in America is that the French know how to do nuclear power. They know how to do it right. And I'm frequently told by people, why can't we do it like the French? Now, we're going to be posting on our website a report that you published, and it's fascinating because the topic is nuclear power in France beyond the myth. And that's really what I'd like to talk about today. So the first question is this. It's well known that France has the highest percent of nuclear power for electric generation in the world, with about, it had been as high as 80% of its power coming from nuclear power. Was that a decision that was voted upon by the French?
No, there was never a vote on nuclear power to begin with. Like when the first program was launched, the first large program was launched in 1974. It was a government decision, and it was pushed through with the elite technocrats without any kind of consultation or vote or anything else. The current level of electricity generated by nuclear power is, though, a little less. It's something like 73%. But you can say it's been for a number of years about 3/4.
Okay. Now, is that going to be the trend in France in the future? Are energy planners planning to be at 3/4? Or where is the French electric nuclear contribution going in the future?
Well, it's very interesting to actually note that there's very little attention internationally to the fact that the National Assembly in France just voted legislation in October that puts out a new target for nuclear power to bring down the share from about 3/4 to half of the production of electricity by nuclear power by 2025. Now, if you look at the attention that gets the nuclear phase-out decision in Germany, where they are left with 9 nuclear power plants, we are talking in France to shut down something like 20 or more nuclear power plants, depending on the level of consumption, of course, at the time of 2025. In order to go down from 3/4 to half of the nuclear production, the electricity production. So that makes the German nuclear phase out actually as a modest project.
So, it's interesting. It looks like the French decided to build an enormous number of nuclear plants as a result of the Arab oil embargo in the 70s. So their plants would have basically been new in 1980, which means they're a little bit newer than those here in the States. So 1980 plus 40 years is around 2020 or 2025. So you will be getting to the point where these plants have reached the end of their 40-year life expectancy.
Very true. We have now an average lifetime, which is, about the average of the world's average lifetime, which is 28.5 years. It's a little less in France, but it's roughly the same. So very true. In the next 10 years, we're going to reach most of that reactor fleet, reaching 40 years operational lifetime, and therefore a lifetime that is considered at this point the end of the operational design basis. And there's the nuclear safety authorities made it very clear that at this point there's absolutely no guarantee that they will authorize these reactors to operate longer than 40 years.
Okay, so what will replace nuclear in that mix? What's the energy plan moving forward?
Well, that's French style. We first have targets and then we wonder, how do we actually get there? So at this point, I cannot, say that there's a precise, clear strategy that has been voted on. For the time being, it's a clear target. By the way, it's also a very ambitious target to get the final energy consumption in 2050 down to half, which is, staggering if you compare it on the international level. How to get there? Well, we'll see. There are some engagements towards the European Union, so France has to boost renewable energies, and at the same time they have to deal with carbon emissions as everywhere. So it will be definitely a challenge to actually get this done, and it's clear that most of those reactors will not be replaced at all. There is an interesting statement by the most senior government bureaucrat in the Ministry of Ecology that is in charge of energy. He's the Director General of Energy and Climate Change, and he stated in front of an inquiry committee at the National Assembly that there might be a non-besoin, like a no need, for around 20 nuclear power plants, nuclear reactors by 2025. So it's basically the idea that, there will be a lot of efficiency needed anyway to get consumption down. And therefore, a lot of these reactors will simply not be needed and not needed to be replaced. Yeah. Otherwise, it's clear that the potential for combined heat and power, trigeneration, and the whole range of efficiency and renewables is highly underdeveloped in France.
Huh. We always think of 80% or 75% nuclear means that's the total energy picture, but really that's not true. The electric segment of the total energy picture in France is a small piece. So what fraction of the total energy that France consumes, for home heating, for automobiles, et cetera, is coming from nuclear, and how much is fossil fuel?
Well, actually, if you add it all up, and what is important for people to understand is that we have to look at what is called the primary energy input. So if you burn uranium or you burn gas or you burn coal, of course, a lot of it is lost in terms of waste heat. In fact, most of the coal plants and nuclear plants have an efficiency level that is only about a third. The best gas plants now do more than 50%, but still more than 40% of that primary energy is lost in terms of waste heat into the environment. So the question is, how much actually ends up at the final consumer that uses the electricity in this case? And if you then look at how big is the share of nuclear, then it's currently around 17%. So it shrinks from about 3/4 for electricity to 17% in final energy.
I have to note, your paper is brilliant on this topic. It talks about how France has such a huge amount of electric coming from nukes, and you want to keep those running, that they're one of the few developed countries that actually has a large amount of electric heating of their homes, essentially because if they don't, they have to shut these nuclear plants down. There's clearly a huge energy efficiency there to get rid of that electric heating.
Absolutely. I mean, in my opinion, my personal opinion, electric space heating should be prohibited. Because, basically, take the same example. If you generate electricity, you lose more than two-thirds, up to 3/4 of the energy on the way, and reheat air or water. So you lost basically 3/4 of the energy on the way. rather than, heating gas or heating, by other means. You can also do solar heating. There's many other ways. And first of all, to insulate the homes properly to begin with. This was meant really because there was an over-dimensioning of the nuclear build program to basically push electricity into monopoly markets, and that's a typical use of that. Now, the result of this is terrible, not only in social terms, because, in nuclear France, which is proud and announces everywhere to have some of the cheapest kilowatt-hour prices for residential and industrial customers, we have now officially 5 million households in energy poverty. 5 million households means over 11 million people. An official paper says 3 million French households, people are cold in winter. So that is the outcome of the energy policy. Why? Because electric space heating is very inefficient, and it leads to huge consumption of kilowatt hours. But on the other hand, there is also a very devastating effect on the electricity system. It rips apart the energy system with very low consumption in the summer and very high consumption in the winter. It's now a factor of 3 higher, the peak load in the winter than the lowest day in the summer. To give you an idea, when the thermometer drops 1 degree in winter, the need for additional capacity is 2,600 megawatts. So you need, every time that the thermometer drops 1 degree, which happens, we have drops of 10 degrees. 1 degree means you need the equivalent of 2 large nuclear reactors additionally. So it's a very fragile system.
Wow. I'd like to go on. One of the things one of the misperceptions about the French nuclear power program is that the French recycle all of their nuclear fuel. That they can take the nuclear fuel from the first batch, send it off, and reuse it again and again and again. That there's an impression here in the United States that there is no waste from the French program. So could you talk about the French recycling program?
Well, first of all, I don't like the term recycling because it gives the idea that there is reuse of the entire materials that you actually, that would be otherwise considered waste. In fact, what happens, the spent fuel or the used nuclear fuel that in countries like the United States is put into dry storage first, in ponds close to the reactors, and then into dry storage. In France, it is after a few years storage, it's sent to the Le Hague so-called reprocessing plant. In fact, it's called in French usine de plutonium, which means plutonium factory, which I think is a much more appropriate term actually than reprocessing plant. There it is chopped up after another few years, and then it's put into an acid bath, and the various substances are extracted. The objective of reprocessing is mainly to extract plutonium. Originally for nuclear weapons purposes, and then there was a big dream of plutonium-fueled fast breeder reactors, where the basic idea was to generate more plutonium than they would consume. A wonderful dream, isn't it? I mean, you create more primary energy than you actually consume. Jesus, I totally understand the kind of fascination that had. The problem is the fast breeder reactor dream is already dead since the middle of the 1980s. But now, since the French nuclear elite technocrats never make a mistake, they never, admit that they were wrong and radically change strategy. So what they do is they adapt strategy. So some of that plutonium is being used in so-called mixed oxide fuel. It's produced in a facility in the southern France. And then this mixed oxide fuel, this MOX fuel, is sent back to, at the most currently 24 reactors that are licensed for the use of that fuel. However, let me point to a couple of major issues. First of all, in the accounts of the owner of that material, the plutonium and the reprocessed uranium, those are the two materials that are extracted for further use, the value, the book value, is 0. Now, I have never, ever heard of an industry that actually generates a product that has a 0 book value. In fact, it has a negative market value, because if you try to sell plutonium, you will find out that you have to pay somebody to take it. I mean, we're not talking terrorist organizations, of course. We're talking the international energy market. You cannot sell plutonium. You have to pay people to actually take it. So picture this. You have a facility that puts out thousands of times the radioactivity that is emitted by a nuclear power plant into the environment in gases and liquid form, that leads to over half of the actual collective dose for the European population. And all this in order to generate a substance that has a 0 book value and a negative market value. Does that make any sense to you?
You know, we have the same issue here in the United States. To make a bundle of mixed oxide fuel costs more, $1 million more per bundle, than to take the uranium right out of the ground. So again, when you try to use plutonium in the fuel cycle here in the States, it actually is more costly than just directly mining the uranium. So you've built up, if I remember right, 56 tons of plutonium that's just kind of hanging around. Is that true?
Yes, that is the amount of unirradiated plutonium. But you see, the problem is that this strategy is actually not even, it's not separating all the plutonium and the uranium, and it's even using less than what is separated in the first place. So this strategy has actually made all of the issues worse. We have a gigantic backlog of spent fuel, which is now approximately 14,000 tons, of which about 10,000, close to 10,000 tons, are stored in 5 pools, unprotected, non-hardened pools at the La Hague reprocessing plant, which I consider is a pretty much of a security nightmare. And we have, you know, another 4,000 tons approximately that are in the nuclear power plants. So these stocks, you know, increased. And amazingly enough, when France started this strategy of plutonium extraction and use in 1987 was the first light water reactor loaded with MOX fuel. At that point, France did not have any significant stock of plutonium, of unirradiated, separated plutonium. So in fact, this whole strategy which was meant to absorb stocks, led to the justification to actually build them up. And today we have, you know, all the problems. We have environmental pollution, we have stocks of spent fuel, and we have stocks of unirradiated plutonium. If I can just add one additional point. This is a system. This is not something which is one facility. You need to combine all these facilities, and combining these facilities means transports, shipments. So we have about 2 plutonium shipments between 100 and 200 kilograms per week that go on a 1,000-kilometer trip by truck over public roads, you know, between the La Hague facility and this in the south, where the fuel fabrication facility is located. So we have a permanent threat of exposure to attack, to accident, and to other problems that we you know, everybody can imagine.
You know, I should remind our readers, it only takes about 10 kilograms of plutonium to make a bomb. And here you are shipping 200 kilograms around the countryside twice a week. Clearly, I can understand your threat from terrorists, from moving a bomb-grade material on public roads.
Well, most recently, we had a very strange phenomenon here in France. It was reported that there are at least 15 nuclear sites that have been overflown by drones of various sizes that have not been identified. The authors have not been identified, and the purpose has not been identified. Now, it might well be that in this case, this is not a very serious threat. This could be all kinds of competition between amateurs of these flying objects, or it could be something else. But just imagine that this kind of pattern would be used by people that have very clearly other intentions. Mm-hmm. It shows a way how to get very precise, high-resolution images of details of nuclear facilities. And this is not even looking at an issue like plutonium transports yet. So it's a very fragile system that is very much attackable, and it's highly exposed to safety and security risks.
You know, the Nuclear Regulatory Commission here in the States is very worried about drones as well. It doesn't even take an attack on the containment from a drone, which would be unlikely, but more likely an attack into the transformers, which would short out the transformers and cause the plant to collapse. If you couple that with some kind of a terrorist action, it suddenly makes the threat much more severe. So yeah, when I read about the drone issue in France, I can just see we'll have it here in the States within a year or so.
Well, you know, I mean, I always say it's very strange if people argue the several meter thick containments as if, you know, an attacker would go for the hardest piece. An attacker will always go for the soft target and not for a hard target. You don't even have to discuss details where soft targets are, but there's loads of them. It's very clear that there are many possible ways, many scenarios how to attack, you know, such a facility. And people forget that, you know, you go on an airplane and you're not allowed to take liquids on there, even small quantities. You're not allowed to have more than 100 grams of toothpaste. And the reason is that if you think back in 1988, when the Lockerbie plane, that was a 747, was blown off the sky, that was approximately 300 grams of explosives. So 300 grams can be easily transported by any size of a small drone.
I wanted to go back for 1 minute. The Le Hague reprocessing plant, and I'm sorry I've not pronounced that right, is near the North Sea. And I understand that there's contamination in the North Sea as a result of the discharges from that plant. Is that true?
Well, of course it is true. I mean, the basic strategy that has been taken there is the strategy of the high chimneys of the factories of the 1960s. The higher the chimney, the more pollution gets dispersed. So the solution to pollution is dilution. That's a very old saying, right? And
I learned that in college.
There you go. So whether we talk about chimneys or we talk about pipes that go into the sea, the strategy is the same. And just to give you one example, iodine 129 is entirely filtered out of the gases because the gases dose impact on the local population would be very severe. But it is filtered out of the gases and entirely 100% pumped into the sea. Now, iodine 129 has a half-life of 16 million years. So you ask me whether the sea gets contaminated? Yes, it does. And not only does get contaminated, it gets contaminated forever.
Wow. The last question I'd like to ask is on the very end of the nuclear fuel cycle. We, of course, had Yucca Mountain, and we may again have Yucca Mountain as the location of the first of many nuclear waste storage dumps where the fuel will go essentially forever, more than 250,000 years.
Maybe.
Do the French have a program, and do they have a mountain set aside, and are they already putting nuclear waste into the earth?
Well, no, not high-level radioactive waste. There is a laboratory that is being built in the eastern part of France, which is in a clay formation. I have called this a long time ago the Trojan horse for radioactive waste, because it's basically designated or not named a laboratory, but de facto it's very clear that the strategy is to transform the laboratory into a final disposal site. But it turned out that research and public acceptance is much slower and much less acquired than anticipated. So we're looking into a long period of time yet before commercial quantities of radioactive waste can go underground. There are other facilities that other disposal sites that have accepted radioactive wastes of various qualities. One is very close to the La Hague reprocessing facility, and another one is actually pretty close to the final repository, which they will want to transform from the Bure laboratory.
Here on the border between Canada and the United States, the Canadians are proposing an intermediate facility on indigenous people's lands. But it's pretty clear to most of us that after the intermediate facility is put in place, right behind it will be, high-level, essentially nuclear fuel forever. And our concerns here are that it contaminates Lake Huron and the entire Great Lakes system. And it sounds like that the approach that the Canadians appear to be taking on the northern border of the United States is pretty similar to what you're experiencing in France as well. Get your foot in the door with intermediate waste and then say, oh, we might as well put the high-level waste there too.
Well, I think it's in the French case. Well, first of all, let me make one comment. I have always refused the term fuel cycle, because it suggests that there is actually a functioning circular economy, which is not true. So I think we should talk really about a fuel chain. That is a much more, precise or a much more coherent denomination to what is actually happening. And it ends up with waste, right, which goes nowhere. So it's well an end and not sort of a circular industry. I think the French strategy is really that something that is called a laboratory will be switched to a final disposal site, rather than using lower level wastes first and then higher level wastes. So it's a different scenario. But I think that in many cases, in many countries, many experts say we don't know what to do with high-level radioactive waste. One thing we agree on is that it should go into geological storage. Well, I'm part of maybe a small minority, but I was never afraid to belong to a minority. I don't think it's a good idea. And I don't think we're ready to actually decide whether this is the best thing to do. So in the meantime, I do believe what is relatively quickly possible to do is to create either subsurface storage or other ways of hardened storage, intermediate storage facilities that can be in a mountain, like the Germans have done it, or it can be subsurface hardened, or it can be buildings. But that allows much easier to get back to the materials and recondition them or find another strategy to dispose of them in a permanent manner.
And my last question is this. France has what had been the two largest players in the nuclear game. EDF, your utility that ran all the nuclear plants, and a company called Areva that actually was responsible for building the plants. They've had pretty severe financial reversals lately. What's the cause and the ramifications on the French program with the financial goings on that Areva and EDF are experiencing?
Yes, this is actually a very serious issue, in my opinion. If EDF is Électricité de France. It's a majority state-owned company, and Areva is the largest nuclear builder and fuel company in the world. Both of these companies have seen their value on the stock market erode to a phenomenal dimension. EDF lost over 70% of its stock value over the past 5 years or so, and Areva up to 85%. This is a clear signal that investors do not believe that, coming out of the 2008-2009 crisis, these companies will actually manage to pull it off and, develop a strategy that they have confidence in. Now, what the investors do on the stock market is, might be their thing, but it's very serious. It can have very serious implications for the safety issue. It can have very serious implications for long-term, nuclear materials management if these companies are actually threatened in existence. And I honestly do believe so. EDF has a huge debt load of over 30 billion euros. That is, way over $40 billion debt load. That's the kind of level that countries have debts. And, it's not a situation where you would say, well, the crisis is going to be over and there's going to be, a better times are coming. In fact, it's the opposite. Worse times are coming. There's less clients, very severe competitors, and they will sell less kilowatt hours. So, and that in an environment where, we're post-Fukushima, there's very significant backfitting operations to be financed. How is this all going to work? Nobody knows really where the money is supposed to come from. And, we're in the middle of an energy revolution, really. When you see that in the US now, you have companies that guarantee photovoltaics installed, banking done for 10 to 20% below what the utilities offer. Jesus, we don't even have these companies yet in France. So in the future, it will be even a lot more difficult for a company like EDF to survive. And the same is true, even more so for Areva, that is stuck in the nuclear business.
We have several examples here. Here in Vermont, we had Vermont Yankee, which was owned by Entergy. And what we found is that as the stock prices declined, the money, the capital that was available to be poured back into the nuclear reactors also declined. And they wound up skimping on safety concerns. And of course, it sounds like the same thing is possible as the stock prices decline. That's the investors who cares. But when the people of France are put at risk because there's not enough capital to invest in safety, that must become a pretty serious concern.
It becomes a very serious concern. It becomes a very serious concern for the entire utility industry in Europe. You have to picture that the 20 largest utilities in Europe lost half their stock value since 2008. Now, half of their stock value means €500 billion, 500 billion euros. Those are dimensions of money that you can hardly even, picture. So this industry is in great crisis, and most of these utilities are actually nuclear utilities. So this is not only a national phenomenon. This is an issue for all of the European nuclear utilities, and it can have dramatic consequences for the, guaranteeing the financing not only of the current operating reactors, but what's going to happen to decommissioning cost, waste management, disposal, et cetera, et cetera, et cetera. I mean, there's a huge backlog of expenses that have to be managed in the future.
Before I sign off, is there anything else that you would like to share with us that I haven't covered?
No, I think, well, maybe one thing. I think that it is remarkable to see that we have now large banks and financing institutions that do their own energy strategy assessments. And they come up with remarkable papers, even over the past 2 months or so. Citi, which is one of the huge banks, published a paper called Energy 2020. We're not talking 2050 or 2100. Energy 2020. The revolution will not be televised. I mean, that's a title of a bank, a huge bank, because they say that, the competitors on the renewable side, for example, are a direct threat to the utility industry. Same assessment by companies like the largest Swiss bank, UBS, that calculated that, PVs plus storage plus electric vehicle will be a system that has a payback time by 2020 of 6 to 8 years in a country like Germany. 6 to 8 years, that means it's affordable basically for everyone. If that is the case, what will the utilities sell tomorrow? And in that context, it is really extremely urgent that we have a very large debate on the future of these nuclear utilities and the management of the nuclear sector.
Well, thank you very much. I refer to building nuclear power plants as building the Maginot Line all over again. And of course, you and France would appreciate that. The Maginot Line was designed to fight the war before, not the war in the future. So I think we're tying ourselves into large behemoths, which is last century's war. When I went to college, that was the only way we could do it. But times have changed, and in the 21st century, it's time for a 21st century look at the concept of baseload power and whether, in fact, we really need that.
The concept has been flying out of the window already, and that is the most interesting. It's gone, and it's just that, and I totally agree, if you today decide to build a nuclear power plant, it's like, investing in a dinosaur and put it in a flower garden. It's just not the appropriate size. It's too slow. It's too big. And it's not at all within the kind of system that we're very clearly are in the course of developing. It's shifting from vertical integration to horizontal integration. And the future energy system will very much look like the internet. It's computing power today is not in one computer, huge size computer. It's millions of computers. And so today we have 1.4 million electricity generators in Germany. There's over 2 million electricity generators now in Australia. So, it's going fast. It's a revolution that is underway, and it's very fast.
Well, the revolution will not be televised, but this interview will be. And I wanted to thank you very much, Michael Schneider, for spending the time with us from Paris today.
Pleasure. Thanks for having me, Arnie.
I'd like to take this moment to thank all of you who supported us here at Fairewinds Energy Education. It takes a good deal of effort and a solid crew to keep Fairewinds sailing. Yearly, we ask for donations of any amount that you're able to give. Every donation is greatly appreciated and enables us to share worldwide the truth about nuclear power. I'm Arnie Gundersen. I'll keep you informed.